It's a little something for the kids. All right, speaking of kids, 1,500 high school students from across the United States and Canada are here for the first robotics competition. Talk to my Highland Robotics team, and they are the Highland, what's the mascot?
The Hornets.
Okay, but we're calling you guys a Sting. Okay, break it down for me. Here we go.
Right, so as you can see here, this is a 3D model of our drivetrain.
Gotcha.
On the front, we have a ramp to cross the barrier. Basically, what we wanted to do was we need to be above the midpoint of the barrier.
Okay.
And how it comes up is on here is the ramp. We come up and we slide over the metal of the barrier. And then it comes up with, here's up close.
Gotcha.
And we have high strength gearboxes and motors. That way, when we're up on the ramp, we can successfully push right over it. Yep.
Okay. You got a little overdrive, basically.
Oh, yeah.
Nice. Okay, what do we have over here?
All right, this is our schematic of our pneumatic system for the robot. Basically, we got a compressor sending air into the robot. We regulate it down to 60 psi. Then we go to our shooting mechanism, which is the main pneumatic system.
Okay.
We fire a piston at high speeds, which shoots the ball towards the hoops during the game.
Okay.
And then we have a vacuum generator that uses airflow to create a vacuum in the exhaust port of the piston, which draws it back to its original firing position.
All right. So now, how many balls can you guys gather and shoot at one time?
The rules state that we can have 3 balls within our frame at one time.
Okay. Can this handle it?
Yep.
Okay. Very good. Now, who came up with the concept?
It was a lot of, we met at a library 4 hours after kickoff, and we all deliberated kind of what we wanted to accomplish this year.
Yeah.
And basically, all the ideas kind of came together to form this robot. It wasn't one person's idea.
All right. I'm looking forward to checking it out. Good job, guys from Highland. All right, 10 seconds. Good morning, everyone. We are here at the CSU Convocation Center, and we're hanging out with some of the brightest kids in the entire United States of America. That's right. They are participating in the first robotics competition sponsored by NASA. And these are the kids from Highland High School out of Medina, the Hornets, but they're the Sting, because they're going to sting them. Okay, so we talked about schematics. Let's talk about the materials you guys used for this robot.
So for our frame, we went with an aluminum C channel. It's lightweight, durable, very good. And then for our drivetrain, we have 2 high traction wheels that give us a lot of pushing power, as well as the Omni wheels on either end. They allow us to take hairpin tight turns around corners.
So these maneuverability
yes,
over here.
they can slide back and forth on the ground.
Oh, yeah, okay. Gotcha. And then this
is a high traction, so we can get a lot of grip onto the floor for when crossing the barrier or balancing on the bridge.
Excellent. Like the way you're thinking. Okay, what do you have over here? Come over here. Okay.
Thanks to Mr. Reichel of Fluid Trolls, we were able to use this extruded aluminum for our superstructure here.
I got you.
And for the piston superstructure here. And I'd like to thank our other sponsors, Viasat, EBO, and Lockheed Martin. And
you're very smart to get those sponsors. That's how the country works.
Yeah, the rest of our sponsors can be found on highlandrobotics.com.
Very good.
And now I'd like to give it to my friend Mark here.
Well, Mark, I'm going to run over here because we're coming close on time. Let's pop over here to my guys from Highland. All right, Highland, what do you guys want to show me?
We want to show you some of the systems. My friend Mark Bloom is going to go through those.
All right, Mark, here we go. Do your thing.
Some of the sensors that we use on the robot, in our autonomous mode, we use a gyro sensor for after we shoot our 2 balls, we turn around 180 degrees so that once we go into teleop, the operator control, we can quickly get the bridge down, get some more balls on our side.
That's cool.
We also have our remote-controlled pan and tilt camera so we can see the hoops, we can see the balls. And when we're going to collect the balls, we also have a proximity sensor that will be mounted right here so that we can tell exactly when to turn on our conveyor belt system. And then we also have a pressure sensor that tells us when, if we have enough pressure to shoot the ball into the high hoop, which we always aim for. And
the high hoop, more points.
Points, exactly.
Yeah.
And so Ryan's going to talk a little bit more about the actual shooting mechanism.
Okay, Ryan, the shooting mechanism. Talk to it.
Yep. So this is, it's kind of covered by the bag right now, but this is our piston that we use to shoot the balls. Usually there's a plastic plate on there that we have to add when around 8:30 when we open up the bag. We have a compressor mounted to the robot underneath, and it goes through a systems of valves and tubing in order to get pressure to this system. And we have this angle optimized for the high hoop.
For the 3-pointer.
Yep. So we can
go for the money.
Points.
Good man. All right, my guys from Highland, my guys from Mid Park, they're going to compete against 15. Well, there's 57 teams these 2 guys are going to compete with. When we come back, we'll be able to see their robots because the rules will allow. All right. Back to you guys in the studio.
They will come to life.
Very cool. Yes, they will.
Cool. Thanks, Kenny.